Hello friends, today we'll start discussing about the second topic which is mentioned in our syllabus, Sociology paper 1. Till now, we have covered sociology as a discipline. So we discussed about the different conditions in Europe which led to emergence of sociology. But when sociology was in the initial phase, there were different questions raised about the scope of the subject. So we discussed about the scope. What does sociology cover? And it has a very wide scope. It can talk about regular interactions among people. It can also talk about issues between nations. All these things can be under the scope of sociology. And we also looked at the different schools, the formal school, the synthetic school. What are its views about the scope of sociology? At the same time, there were some questions raised by some other social scientists from other disciplines regarding the subject matter of sociology or the methods of sociology. The questions that were raised was the things that sociology is trying to study. We are also doing the same thing. How is sociology different? So we saw the different comparison between sociology and history, comparison between sociology and political science, psychology, economics, multiple disciplines. So, and we found out how they can be different, how they will have divergence, but at the same time, we also saw that there can be some convergence. And we also discussed the difference between sociology and common sense. Because sometimes there is this question raised that what sociology is trying to do, that is nothing but common sense. But yes, they are different. They're not the same thing. Common sense is different, sociology is different. Sociology is an attempt to scientifically study society. Scientifically, systematically, you're trying to study society. So in this section, we will try to understand how sociology is a science. So you can look at the syllabus, the name of the topic is sociology as science. We'll be discussing that. And under that, there are multiple subtopics. So first topic, science, scientific methods and critique, that is what we're going to do in this present session. So what we'll be doing in this entire part, sociology as a science part, is we'll try to understand what science is. We'll try to understand what scientific method is. Then we'll see whether these methods can be used to study society. So we'll understand what is positivism. To this also there are different criticisms. So we'll understand non-positivism. We'll also look at certain things, certain concepts which are very important for understanding society or for basically researching about society. So we'll be understanding fact, value and objectivity, how they are important in social research. And we'll also be looking at multiple strands of research, sociological research. What are the different schools of research? We'll be looking at that as well. So we'll start with science, scientific method and critique. So first what we'll do in this session is we'll understand what is science, what are the different elements of science, what is the goal of science, how scientific, what is the scientific method, what are the steps to be followed if you're using scientific methods. And then we will see some of the criticism of these methods. So all these three things will be covered in this session. First, what is science? What do you understand by science? Now you can look at the definition that is there on the screen. Simple definition, it is a body of knowledge. Systemized body of knowledge, and this knowledge is acquired through sensory observation of empirical data. A very simple definition. Another way also, you can define it. Science is a systematically acquired, organized body of certified knowledge. It is on the basis of observable facts. It is also on the basis of methods that is used to acquire this knowledge. So it has some facts, it has some methods, and it is an organized body of knowledge. Okay, these things you keep in mind. Sensory observation means something you can see, something you can feel. So that is sensory observation. So science is a systemized body of knowledge. So the knowledge that is there is organized in a particular manner, and this is all on the basis of empirical data. And this data is collected through sensory observation. To understand science, again, one example I can give you. Or we can do one thing, we can understand what is religion, let's say. Religion is also a body of knowledge. Religion also talks about a lot of things. So it will say, do not kill someone, violence is not good, love your neighbor, speak truth. So that is also religion. It has some knowledge in it. But the knowledge it has, it is not on the basis of empirical data. You cannot test it. What do we mean by empirical data? That means data which can be verified, data that can be observed, data that can be quantified. So the religious knowledge that you have, that is not empirical. But scientific knowledge, it is empirical. You can quantify it, you can observe it, you can classify this. So this is something which sets science apart. And all these information you can acquire through sensory observation. When a scientist is studying something, he's collecting the data, he's using his sensory observation there. He's seeing something and he's noting it down. So this is the definition of science. Systemized body of knowledge, arranged in a particular manner, it is organized based on sensory observation of empirical data. Now, what are some basic characteristics of science? Already we have seen a couple of things here. We'll look at all the points again. So science is characterized by empiricism. Science is characterized by objectivity. It is characterized by its self-corrective nature. What is empiricism? I already told you. The data that you are collecting, the facts that you are observing, you're studying those facts. But these facts are quantifiable. They're not qualitative, quantifiable. They're verifiable, they're observable. They're observable from outside. Different physical phenomena, they're all observable from outside. They're verifiable. You can have experiments to verify that. And they're quantifiable. You can give some units to that. You can measure it. So science is based on empiricism. Also, science is characterized by objectivity. Now, what do we mean by objectivity? Objectivity means it is a frame of mind which is free from any prejudices. It is free from any preferences. It is not biased. So science is objective in its nature. For example, there are mechanisms by which a cell divides into smaller parts. Okay, cell can divide and form new cells. One cell gets divided and it can form two cells, it can form four cells, mitosis, meiosis, different processes are there. So it is a fact. There will not be any objectivity here. You just observe that, it's fine. There is no value here, whether it is good, whether it is bad. Science is not saying that. So it is objective in nature. I'm not saying whether it is good or bad. If let's take the example of religion. Religion will say this is good, this is bad. Or moral values, whatever are there, moral guidelines, whatever are there. They're also body of knowledge. They will say it is good, that it is bad. But science does not quantify it like that. Science does not classify it like that. So it is free from preferences and prejudices. Another thing here, science is self-corrective in nature. Science is not absolute. Science is not concrete. At present, we're studying something. We're studying some sciences. But it might so happen that in the next 5 years, 10 years, or maybe 50 years on the road, someone comes and he says that no, this is not correct. There is some new research. He found out there is a scientist through some new research, he has found out something new. And he says that what we are studying, that was possibly wrong. Now there is an improvement. So the new body of knowledge, the new body of scientific knowledge will carry that. It will not accept what we are accepting it right now. So science has the capacity to correct itself. The cultural tool that we have, religion that we have, it does not have this capacity. It has been the same in the past, now also it is the same. So science is characterized by self-corrective nature. It is open to rejection. It is open to rejection. Just think like this. At some point of time, people believed that the earth was at the center and everything revolved around the earth. Later on, someone is coming and saying that no, it is the sun which is at the center, other things are revolving around it. So the body of knowledge is getting changed now. And over a period of time, there are other changes as well. At some point of time, it was believed that light is a wave. Then someone came and said that it is particle. So these theories, the scientific theories, they can change over a period of time. They do not say that they are always the same. So this is also a very important feature of science. So science, it is a systemized body of knowledge based on sensory observation of empirical facts. It is characterized by these three things: characterized by empiricism, characterized by objectivity, and characterized by its self-corrective nature. Now we will see some goals of science. What does science seek to achieve? Now, science tries to find answer to different questions. It tries to explain why some things happen and why some things don't. It tries to understand the phenomena and it tries to find out the reason behind the phenomena. But it goes beyond that. It also tries to make generalizations. What is generalization? You study something and then from that you can find out some common patterns. Why this particular phenomenon is happening. If it is happening again and again, you can find out that underlying pattern. And then you can possibly find out a theory or a law that if these are the circumstances, this thing will happen. So this is generalization. So it tries to find out that. Now, if you have developed the generalization, if you have found out the law, that law can be used to predict. It can be used to specify what will happen in future. If x and y are there, x and y are some properties, it can lead to formation of z, provided there is one more condition, let's say T, temperature. So we have made a law now. X and y in the presence of T can lead to formation of z. So now in future, if x and y are there, it can lead to formation of z, but when it might not lead to formation of z. When it will lead to formation of z, provided T is also there. So you are basically trying to predict the future. You are specifying when it will happen. So science also tries to do that. For example, see, NASA sends many space shuttles, and many of these shuttles again they come back. So because of sciences, because of advancement in sciences, they have been able to come up with many generalizations. They know under what circumstances these space shuttles will be returning back. They know if the velocity or the acceleration changes beyond a particular point, it might not reach back because of the friction. It might get burned when it is returning back. It might catch fire when it is returning back to Earth's surface. So because of advancement in sciences, they have been able to find out when all these things are happening, when the friction is so high that it can lead to combustion of the entire body. And accordingly, they have come up with different generalization. And accordingly, they predict that this is the speed, this is the acceleration with which they have to return back to the surface, Earth's surface. So science basically tries to do all these things. What are some elements of science? Now, science basically has 4 or 5 elements, and we'll look at them one by one. First thing here, the use of scientific method. Now, what is scientific method? We look at it in details. Basically, it is a series of steps which needs to be followed. It also includes reliability, validity, generalization, prediction. We'll understand each of them one by one. Reliability means if you're trying to measure something, we should be getting the same results again and again if you're measuring the same phenomena using the same scale. Validity means if you're trying to measure something, so your result will be the same, what you're trying to measure. You should not be getting something else. How effective is your measurement? Whatever you're intending to measure, you're getting the same result. That is being valid. Generalization, prediction, we will see in a while. So we first discuss what is reliability and what is validity. As I told you, reliability means when you're trying to measure something and you're measuring it repeatedly, you should be getting the same results. Then you can say your measurement is reliable. That means it indirectly refers to consistency, accuracy, precision, stability of your measurement, predictability of your measurement. If I am measuring the mass of an object, let's say the mass is 10 kilos. If I'm measuring now, it is 10 kilo. Tomorrow also I'm measuring it is 10 kilo. Today I'm measuring it in the morning and the evening, it is 10 kilos. So that means the method that I'm using to measure it is correct. It is reliable. If you look at reliability, again, it can be divided into 2 types. Temporal reliability and comparative reliability. What do we mean by temporal reliability? If you are measuring something at different points of time, if the result is same, then it is reliable temporally. The same result is obtained when the measurement is repeated at a later time. Today I measure a phenomena, tomorrow also I'm measuring the same phenomena, day after tomorrow also I'm measuring the same phenomena. If I'm getting the same result, it is reliable. Comparative reliability, that means same result is obtained when 2 different forms of a test are used. When the same test is applied by different researchers, or the same test is applied to 2 different samples. There are 2 different samples, but we know that both of them are same. So 2 different samples are used and they are measured through the same method. You're getting the same result. Same phenomena is measured by different people. You're getting the same result. In that case, it is comparative reliability. So keep this thing in mind, that if you're measuring something again and again, you are getting the same result. Different points of time by different people, different samples. See, now the problem with reliability is basically taking into consideration one angle. Let's say there is an object which measures, whose mass is actually 5 kilo, but my scale is wrong. The method that I'm using is wrong, or the scale that I'm having, it has some bias. So it is giving me the result as 10 kgs. Tomorrow also if I measure, it will give me 10 kgs. Day after tomorrow also it is 10 kgs. If I am getting another researcher who is also using the same scale, the weight will be 10 kgs. In this case, what is happening is the scale is actually reliable, but it is not accurately measuring it. What it should actually be measuring, that is not what we are measuring. So scale is reliable, but the scale is not valid. It is not correctly measuring the concept we are trying to measure. So it should have ideally measured 5 kilos. So that is the reason validity is also very important. Reliability is important, but validity is also important. Reliability will ensure consistency, but validity will actually ensure the correctness of the measure. So we also need to focus on validity, that it should actually measure what we are trying to measure. Now if you look at validity, here again there are 3 different kinds of validity. Criteria validity, construct validity, and content validity. 3 validities are there. Now we'll discuss what are these individual parameters, what are these individual types of validity. Criteria validity means how well one measure predicts the outcome for another measure. For example, see, we have these GRE tests people write so that they can get selected for masters, the graduate studies in different colleges all over. Now, see, the score of this particular test is used by different universities to evaluate how well a particular candidate will perform in these master studies. If someone's GRE score is low, then they might not consider them. They can, but most likely they will not. If it is exceptionally low. But you need to have some score over there so that you will be eligible. So here what is indirectly happening is, it is assumed that the GRE scores can actually measure your ability to ace in the master studies, in the graduate studies. So here, if it is true, that means this fulfills the criteria. The GRE test fulfills the criteria of validity. The GRE exams, they are able to, the score of your GRE papers, the score of your GRE test, it is trying to measure your performance in your graduate studies, okay, that you are going to pursue after the GRE test. So this kind of validity is called criteria validity. Now, what is construct validity? Now, what is the meaning of construct here? See, construct means there are certain things which happen at the level of the brain, at the level of the mind. For example, different kind of skills, they will happen at the level of the mind. Emotional maturity, that will happen at the level of the mind. Intelligence quotient, again at the level of mind. So these are called constructs. Whether we are able to measure these kind of constructs, that is called construct validity. If you are able to measure these things, then your method is valid along these lines. See, the problem here is it is not very easy to measure these things, because they are all subjective parameters, and we also do not have scales of measurement for these things. So if you are able to measure these things, then we call it construct validity. What is content validity? See, a method is said to be valid along these lines, or a method is said to be exhibiting content validity if it is actually measuring what it is intended to measure. For example, if I am conducting an exam, let's say I'm conducting a maths exam, the questions that I am setting, it should actually be testing your mathematics skills. If it is testing your English skills, language skills, so it doesn't make a sense. So in that case, it is not content valid. If I've used a flowery language over there, if I've used such a language that understanding the language becomes more important than solving the mathematical problems, then it is not content valid. Or if I've set the paper in such a manner that a person can answer the questions even if that person is not mathematically proficient, then the methodology that I have used is not content valid. So all these three parameters are important when we talk about validity. Criteria validity, how well one method predicts the outcome in another measure. Example, GRE test. Also, you can include example of UPSC exams. When you are appearing for UPSC exams, you are basically getting selected along certain criteria that you are good with all these things. You have some basic idea about general studies, you have some general awareness. Also, you have a certain personality that is tested in your personality test. There will also be a physical fitness test, so you are physically active. At the same time, other phases of the exam, for example, your prelims exam, it tests how you react to uncertainty, because every other question patterns might change. Today it is traditional, tomorrow it might vary. How you react to uncertain circumstances, that is being tested over there. Also, they have some sections, for example, GS4 is ethics. They're also looking at the ethical reasoning part. So they're looking at all these angles, and they feel if you are doing well in these angles, you might be a good civil servant. So criteria validity means how these tests, they predict or they measure the outcome in some other measures. Construct valid, whether you are able to measure certain constructs. Construct is difficult to measure because of the subjectivity involved. Content validity, whether you are actually measuring those things which is supposed to measure. Whether the test is actually measuring those things it is supposed to measure. So all these three things fall under validity. What is generalization? What is prediction? We already have some rough idea about both the things. Generalization means you are basically creating some general laws on the basis of some specific study on some individual cases. So you are taking some individual cases, you're studying those individual cases, from that you are finding out general laws, and these general laws can be applied to the collective. This is the meaning of generalization. From some samples, so when you are going for an experiment, you're not studying everything, you are experimenting on some laboratory samples, and from that you are coming across some finding, some laws, and those laws can be applied everywhere. When Newton is finding out gravity, how is he finding it? First, the apple is falling on him. From then, that is what he is observing, and again he observes some more things around him. From that, he comes up with this theory related to gravity, and again this thing is applicable everywhere. For example, the different planetary bodies, among them also there is gravitational force. He's not going and finding this out, but from a smaller sample he is creating general laws. So generalization is going from individual cases so that you can apply it to the collective. What is prediction? Prediction means you are able to predict some phenomena, you are able to anticipate, you are able to guess, you are able to you're also able to give some prophecies on the basis of your study. So that is called prediction. So if generalization has happened, from that you can go for prediction about future. And what is scientific method? So these are some methods which are required for acquiring empirical data and for processing them, so that you can acquire a law. So how you collect data, how you process data, and how it leads to formation of law. So that is scientific method. It follows certain steps. So the next thing what we'll do is we'll look at this scientific method. What are the different components of the scientific method, and what is the step that we need to follow? First thing here when it comes to scientific method is perspective. What is perspective? What do you mean by perspective? See, what's the meaning of perspective? Perspective means it is your worldview, how you see things around you. That means these are some assumptions. These are assumptions, these are your worldview, how you perceive things. So you start with certain assumptions. These assumptions are referred to as the perspective. This perspective, it gives you a broad view about the nature of reality. You are able to delineate your subject matter with the help of these perspectives, with the help of these assumptions. Next important thing is subject matter. Scientific method will have some definite subject matter, in which area you need to carry out your investigations. That is your subject matter. What is the broader area in which investigations have to be carried out? That is subject matter. Next thing is the body of concepts. To understand your subject matter, you need to use some concepts. They are abstract ideas. And these ideas exist at the level of mind, but they help us to communicate our experience of reality. For example, if I'm studying, let's say mechanics, okay, one of the domain under physics, mechanics. Now for understanding this entire field of physics, I need to have some concepts with me. For example, I need to understand the concept of mass, the concept of speed, velocity, acceleration. These are some basic things which form the body of concepts when you're trying to understand mechanics. Many of you would have read about mechanics, especially if you're coming from science background. So these are the body of concepts. You have to define what is mass, what is speed, what is velocity, what is acceleration, and because you have defined all these things, you can understand this entire subject matter. Similarly, if you're trying to understand society, you need to have some concepts. If you're trying to understand the politics that happens around you, you also need to have certain concepts. For example, if I have to understand the political processes in a country like India, you need to understand democracy. What is democracy? What are the components of democracy? And democracy is only one part. Other things will also be there. So your field of study will have some concepts. You have to define that concepts, and they might be abstract ideas. But keep one thing in mind: if you compare the kind of concepts we will be using when you're trying to understand social sciences, and the kind of concepts these are natural sciences, physics, chemistry, biology, astronomy they use, they're a little different. These concepts are scientific concepts. The concepts that we will be talking about, they will be ordinary concepts. Scientific concepts, they are precise, they're very, very accurate. For example, if you say mass will be defined in a very accurate manner. What is 1 kg? Again, it is very, very accurate. You might have observed in the last few days, last few months, how there was a change, how 1 kg has to be measured. So why this is so important here? Because science, the concept of mass, it is very, very precise, very, very accurate. According to certain things, they will be trying to find out what exactly 1 kg is. But when we say democracy, let's say, it is a concept, but it will not be that accurate, that precise as the concept of mass. Democracy can have multiple features, and these features might not be the same everywhere. I might create an ideal type of democracy, where ideally democracy should have all these things. But if you go to the democratic countries, maybe India, largest democracy, will not have all the features. Or you go to US, there also all the features might not be there. You go to the Scandinavian countries, there also we might not have all the features. So they will not be very, very accurate, very, very precise. Scientific concepts are very accurate, very precise. So keep this in mind. And the next part, scientific method involves a series of steps for collection, analysis, processing of data. We'll see these steps one by one. What are these steps? What are the steps when it comes to scientific inquiry. First thing, you need to have a hypothesis. What is a hypothesis? It is a tentative statement which basically formulates a relationship between two or more variables. X, Y, let's say there are two variables. What is the possible relationship between X and Y? So it can be a hypothesis. How do you generate a hypothesis? From your existing body of knowledge, you generate a hypothesis. So it is deduced from different assumptions. This is very, very general in nature. For example, one hypothesis can be mental illness leads to suicides, or climatic factors, colder climatic factors can lead to suicide. It can be a hypothesis. It can be an assumption. But one thing, if you want the hypothesis to be useful, it needs to be precise, unambiguous, and testable. It should be clear, okay, what it is trying to say. We should be able to test it. So indirectly, what we are trying to do is we are saying that a hypothesis should be falsified. For example, if I say tomorrow it may rain, it may not rain, we cannot falsify it because this statement is always true. It may rain, it may not rain. There cannot be any third criteria. If I say tomorrow it will rain, that means it is falsifiable. Someone can prove it wrong. If it does not rain, it is proved wrong. So we need to keep this in mind that your hypothesis should be precise, testable, unambiguous, so that it can be falsifiable. If it is not falsifiable, then it is not a hypothesis. The concepts used in hypothesis should be operationalizable. The concept that we are talking about, we can operationalize it. For example, if I say tomorrow it will be hot, it is not operationalizable. If I say this year in summers it will be very, very hot, it is not operationalizable because I am not defining things. I'm not having any operationalizable index here. What is hot? We need to have an index to identify what is hot, what is not. What are the summer months? We need to define that. So we can have a hypothesis that next year during the month of March, April, May, the temperature will go beyond 40 degrees. So you are using an operationalizable index, this temperature, 40 degrees. So we need to take into consideration that these concepts are operationalizable. Now hypothesis tells us what kind of data needs to be collected. In this hypothesis, for example, we are trying to find out the temperature data. We need to also have day-wise temperature data. So accordingly, we use different techniques for data collection. Now when you are collecting data, we need to ensure that your data is, the method that you are using for collecting data is valid and reliable. What you are measuring, what you are intending to measure, you are getting the same thing. It should not be something else. And when you are measuring again and again, we are getting the same results. So it should be consistent, it should be precise. And what you are measuring, you are correctly measuring it, validity. Both the things should be there. Now you have to process the data. And then you can test your hypothesis. You can find out whether whatever you had said as per the hypothesis, the data is also saying the same thing or not. If it is correct, if the data is matching with the hypothesis, data supports the hypothesis, that means the hypothesis is proved correct. You can go for repeated testing of this. And if you're testing it repeatedly and you're getting the same result, it will lead to generalization. You can create laws. And a higher level of generalization is theory, and even a higher generalization is law. A theory which is applicable universally, everywhere, it will be a law. So start with hypothesis. Hypothesis needs to be falsifiable. That means it has to be precise, unambiguous, testable. Someone can test it and can say that no, it might be wrong as well. Then collect the data, ensure that you are following validity and reliability while you are collecting the data. The methods are reliable and valid. Then measure whether your hypothesis and the data that you are collecting, they are matching together or not, they are supporting each other or not. If that is correct, repeat again and again till you get a generalization. Then if you are getting generalization, if it all this is matching, then you will get a generalization. Then go for then test it universally, it can lead to formation of a law. So if you look at it, this entire procedure looks something like this. From your existing body of knowledge, on the basis of certain assumptions, you are linking some variables. That is leading to formation of hypothesis. Now you are collecting data according to the hypothesis. Okay, whatever is required, those data you are trying to collect. You are processing the data. All the data might not be relevant, some part of the data might be relevant. Now you are processing the hypothesis with the hypothesis and data that are supporting each other. It might so happen that data and hypothesis are not supporting each other. So you will try to modify the hypothesis now. You want to modify the hypothesis, again it will come here, the same part, same thing, and it will add something. You might have observed something, so existing body of knowledge is also getting enriched. You know that these two things are now not linked with one another. X is not leading to Y, X is not causing Y. So that is also getting to your body of knowledge. And again, you might modify it, and you might have come across some other factors, create a new hypothesis, and come to this process, this step once again. You can again process the hypothesis. Now if data is supporting the hypothesis, it leads to formation of thesis. Test it repeatedly, again and again, universally, it will lead to formation of law. And again, this law is also adding to the existing body of knowledge, something new that we have discovered now. So this is the entire methodology of scientific inquiry. Okay, what are the procedural steps that you are trying to follow when you are going for scientific inquiry? So from the existing body of knowledge now, we can create more hypotheses. So this cycle keeps on continuing. At this step, what is happening here is your data and your hypothesis, they are matching together. And now you are going for test, you are repeatedly testing it. You are going for generalization in this part. Now, why generalization is happening here? Because there is a pattern. Only if there is a pattern, then your repeated observations or repeated experiments will give the same result. So this process of generalization is trying to discover the underlying patterns. And if you are discovering these underlying patterns, then this can lead to formation of thesis, theory, and law. So this is true because there is existence of a pattern. So this is about the scientific method. Now this method can also have some limitations. We'll see those limitations, the critic to scientific method. What are some critic to scientific methods? Now sometimes there can be some bias in these methods as well. The tests can be designed in such a manner that it leads to a particular kind of result. For example, you can have surveys which can also push your research in a particular direction. Sometimes even if you're using scientific methods, there is a possibility of some bias. It can happen. Now another issue here is the difficulty in understanding cause and effect. See, science relies on, scientific methods rely on correlation. They will find out the variation in two variables, how these two variables are changing over a period of time. If the change is similar, they will say that there is a correlation. But correlation need not always lead to causation. Two things can be correlated, but not necessarily one factor is leading to another. Let's say there are two graphs. Let's say this is x parameter. Let's say this is y. See, both of them are fluctuating equally over, let's say, another parameter t. But that does not mean that y is causing x, or y is the causal factor for x, or x is the causal factor for y. It might only be a correlation. So sometimes these kind of confusion is there. Sometimes this correlation can be on the basis of incomplete and unrepresentative data. That can also happen. And you'll find many times these mistakes are also made by scientists. Another shortcoming or challenge with scientific method is scientific methods find it difficult to measure subjective parameters. Subjective factors they cannot measure. For example, things like happiness, beauty. How can you quantify these factors? They're all qualitative aspects. They're not quantitative aspects. So it is difficult to measure it through scientific methods. So scientific methods are not universally applicable. So one shortcoming of scientific methods. Now another issue is epistemological anarchism. This concept has been given by one Austrian philosopher, Paul Feyerabend. So Paul Feyerabend, he's saying that this is one of the major issue with scientific method. And what he's saying is how science emerged. Science emerged as a liberating movement. There were different dogmas in the society, different kind of notions were there, different kind of perceptions were there. Religion played a very important role in establishing these dogmas, and no one was allowed to question these. This is like this, you cannot question it. But how is science emerging? Science is emerging as a liberating movement. That no, we can question it, and they're trying to prove it wrong. And they proved it wrong. Many of the dogmas that existed at that point of time. For example, people believe that Earth was flat. People believe that Earth is at the center. All these things are being questioned, and it is leading to emergence of science. So it emerged as a liberating movement. But over a period of time, what is happening is science itself is becoming very rigid. It is becoming a kind of ideology. How? Because science itself is devising different methods. You have to follow these methods. It is saying that you have to follow these fixed universal rules. So all these things is limiting science now. Ideally, it was something which would have liberated people. You can use your own mechanism, you can use your own methods, challenge it. Whatever existing dogmas was there, over a period of time, it itself is becoming like that. And this can be detrimental to science itself. That is what he's saying. Another challenge is science is also vulnerable. The scientific methods are based on existing scientific theories. So they are also vulnerable just like other methods, and they're also not completely perfect. So these are some criticisms of the scientific methods. This sums up our discussion on science, scientific methods, and its critique. Understand what is science, understand what are some of the features, characteristics of science, understand what is the goal of science, and what are the elements of science. Understand what is validity, what is reliability. Both these terms, again, how you measure validity, how you measure reliability, all those factors, temporal reliability, criteria validity, construct validity, content validity, understand those things. What is generalization, what is prediction, and the final part, what is the scientific methods. What is perspective, what is the subject matter, what is the body of concepts, what is the step-by-step procedure. Starting from hypothesis, how data has to be collected, and what are the things which has to be followed while collecting data, while analyzing data, then testing the processing the hypothesis, testing the hypothesis. From that, how there is generalization, and why generalization is possible, how generalization is possible. Only you have some patterns, then only generalization. So those things which are pattern can be studied through this mechanism. So this is the entire process of scientific inquiry. Final part, there is some criticism of the scientific methods. What are these criticisms? There can be some bias. Sometimes there is confusion related to causation and correlation. Correlation does not necessarily mean causation. So sometimes this issue is also there. Scientific methods find it difficult to measure subjective factors. They're very good when it comes to measuring quantitative factors, but when it comes to subjective factors, there's an issue. Science over a period of time has become dogmatic, rigid. It was supposed to be liberating. It has become rigid now. Also, the different theories, they're also vulnerable. Scientific methods are on the basis of scientific theories. Not all theories will be completely perfect. So this is about scientific methods. In the next session, we'll try to see, or we'll try to understand whether these scientific methods can be used to study society. What can be some challenges in that, and what are different viewpoints here? Whether sociology or whether study of society can be a positive science. What is positive science? We'll discuss it in the next session. Positivism, positive science, we'll be covering in that session. So we'll see it there. Thank you.